Good morning, folks. It's hard to see the screen from here. So as Mike said, I'm just going to give an overview of critical minerals. You are actually going to see two talks on them this morning, but David Mate, my colleague from NRCan, is actually down with COVID. So that's okay. We won't overlap and we won't step on each other's toes. So I guess that's the upside. This is not going to be a really technical talk. I'm not talking a lot about geology. I'm assuming it's an audience that's a mix of public and communities and industry. And so what I thought I'd do is a little bit of critical mineral 101. Mike called it a bit of a buzzword, and it's true. It gets used a lot, but I think there's different perspectives on what it means. So Canada, when they rolled out their critical mineral list a year and a half ago in the spring of 2020, defines critical minerals as having three criteria. They're important to Canada's economy. They're required for us to transition to a low carbon future, and also important for digital technologies, both of which are important to Canada. And they also can be sustainably supplied to our trade partners. So in other words, they're commodities that we have in our geologic resources. The little logo on the right with the Canada flag has 31 points on the maple leaf, and it lists the 31 critical minerals on Canada's list. Some people call them critical metals, and I think they can be used more or less interchangeably, but just for the record, not all of them are metals, and I think that's why they went with minerals instead of metals in the name. Critical minerals, battery metals, strategic metals, are a bit confusing. They get used interchangeably, and people are justifiably maybe baffled because there is some overlap, and the definitions not only differ country to country, but they evolve over time. So that's, I think, why people are a little confused. Battery metals are pretty straightforward. They're a subset of critical minerals, but they're those that are used specifically for energy storage. Strategic metals have the added criteria different from critical minerals. They're not necessarily readily available to a country because they don't have them in their geologic endowment, and they don't necessarily have friendly trade partners. And I'll give you an example a bit later about a strategic metal. So the diagram here on the right part of the screen is just meant to illustrate schematically. It's from a publication by the Norwegian Geological Survey, and it shows how over time, you say, well, why would a critical mineral list change? Because our technologies change and society's values change. So in 1700, the cutting edge energy technology was an old-timey windmill. And then in the 1800s, the steam engine was invented, and then that was replaced by the internal combustion engine. And now we've got solar panels and wind turbines as our cutting edge technology. So the commodities needed to build the different components of these have evolved and changed over time. And that's the reason our critical mineral list will be dynamic. I guess what I would say they have in common across countries and through time is that they reflect the needs and values of society at a point in time. So in Canada's case, energy is important, and we value renewable energy. And technology is important, and we value connectivity because we're a big country. Up in the north, we're spread very thinly in terms of population density, and so connectivity and bandwidth are often big challenges for us. So some of the applications, and I think everybody knows this, the Minister Wilkinson this morning in his introduction talked a bit about critical minerals and how they're going to bring us into the brave new future. But it's not just energy, solar panels and windmills, it's the batteries that are needed to store the energy and the transmission lines needed to move the energy among centers. We look at satellites and cell phones and computers, and also a lot of the transportation needs we have as we move transportation to greener forms, electric vehicles, and more efficient aircraft. So basically, pretty much anything you can point in terms of where we want to be in the next 20, 30 years, critical minerals are going to be a big component of that. So what? So that's the sort of Canadian context, but how does this affect Yukon? Well, this document was published in 2020. It's Yukon government's climate change strategy, basically. It's called Our Clean Future, and it's looking at climate change, energy, and the green economy. And it lists a bunch of goals, including adaptation goals for communities that are facing subsidence due to permafrost thaw, but it has a number of specifically energy-related goals. a fairly ambitious target for reducing greenhouse gas emissions. It talks about using more renewables for both power and heating in homes and buildings and along our highways. And it's working on some intensity-based targets for greenhouse gas emissions for mining. So if you think about those goals and think about critical minerals, they're kind of tied together, because in order to have more green energy and more electric vehicles on our roads, we've got to see an increase in the availability of these metals to get there. This is taken from a report that was done by Vector Research for Yukon government a few years ago, and it shows how our energy is produced and how we consume our energy in the territory. And close to 80% of the energy generated in Yukon comes from hydrocarbons, petroleum and propane. Just under 20% electricity, and the rest is biomass. That's obviously heating. But in terms of the pie chart on the right, where we use that energy, a little over half of it is used for transportation. And that's not surprising. We're spread apart. We have small communities. And then the other half is almost equal parts of industrial, residential, and commercial institutional use, so heating and power for those uses. So if we dig a little more closely, specifically into the 80-ish% of energy production from hydrocarbons and the 53% used in transportation, and we want to have this goal in our clean future of reducing our greenhouse gas consumption, then a logical conclusion is that we need to see more electric vehicles on the road. Copper is one of the many commodities listed on the critical minerals list, and here's just some stats on the amount of copper needed to build the average car. If it's an internal combustion engine, it takes about 23 kilos of copper. If you've got a hybrid electric vehicle, then you need about twice that, 39 kilograms. And if you go to a full-on electric battery-powered vehicle, it's 83 kilograms of copper. So you can see there's a significant increase as you get more electric and less reliant on gas. Beyond gas, or beyond rather batteries for our vehicles, we need the power infrastructure to charge them. We need heat for our homes and power for our homes and businesses. And so just a few examples of how critical minerals may be applied on these fronts. And when we talk about batteries, there's batteries in your vehicle and batteries maybe in your basement if you have solar panels on your roof, but there's also scaling up to grid scale batteries, and those are large storage units. And battery technology is changing, and the battery metals list actually is changing fairly quickly as different technologies are evolved. Solar panels need silver and zinc. Wind turbines use steel, copper, rare earth elements for some of the magnets in the components. And then power transmission, I mentioned, is a big consumer of copper. This leads, and I think Minister Wilkinson alluded to this too, that this creates economic opportunities as well as maybe shining a light on some shortages of these commodities that we have. I'm not an economist, but I'll talk about international trade anyway. So this is a graph created by the International Energy Agency, and it shows the proportion of international trade that occurs in various energy commodities. And the blue bar shows the stats from 2019, so a few years ago. But you can see it's dominated by oil and gas, and critical minerals is just a little bit over 10% of that mix. But if you fast forward to 2050, and this is a bit of a crystal ball forward look, but they estimate if we're to meet the 2050 net zero targets that were agreed upon at the COP26 last year in Glasgow, we're going to see a significant reduction in oil and gas, not a complete elimination of them, but the biggest growth area is going to be in critical minerals. A couple other projections, again, crystal balling, but the World Bank, it shows on the top chart on the left and the bottom chart on the left the respective increases that they anticipate in demand for different commodities that will be needed in wind turbines on the top and solar panels on the bottom. And then another graph from the International Energy Agency on the right, and showing the predictions in terms of the number of times of how many times more of these various commodities we'll need to move into the future to 2040. And you can see lithium in particular, they're expecting a 42 times increase in access to that metal. So to that end, given the buzz around critical minerals, last year the Geological Survey released this report. It's just an inventory of Yukon's critical minerals. And among the things that you'll learn if you pick up a copy are that we have deposits of 12 of the critical minerals on Canada's list. And by deposits, I mean ones that are actually drill delineated and a resource in the ground defined that's compliant with national standards for reporting on these sorts of things. 13 of the critical minerals on Canada's list are known to occur in Yukon. We don't necessarily have defined resources, but there's been one or more in-ground occurrences found. And then there's 6 of them that we don't have any in Yukon, and we're not really expecting to find these because our geology isn't the right setting for most of these. The map on the left here shows the distribution of those deposits that I mentioned, of the 12 commodities. They're color-coded, and we only show the primary deposits. So for example, you can see the copper deposits are shown in a gold color, and I can't point it out because there's no pointer, but Casino deposit also has molybdenum present, so it only shows as a copper deposit, but in many cases there's more than one critical mineral commodity in these things. So where do we fit in the Canadian context in terms of what we're contributing to the critical mineral pipeline? We're very modest players. Minto mine, over its life, has averaged 15 to 30 tons of copper per year production. Canada reports about 500,000 tons per year of copper, so we're less than 0.01%. It's a small deposit, Minto, but a very rich one. But it's still, we're not big players in this space. And ditto other critical minerals. The Keno mine, when it was operating, and it'll be coming back into production again, we expect, it's primarily a silver mine, but it does produce zinc and indium as byproducts. And so I think overall, although we do have some resources in the ground, we're very modest players in terms of what we're contributing to the global supply. So I'll just give a few examples of some of the main critical minerals that we have in Yukon, and I'm not going to go through them in detail, but I do have a couple copies of this critical mineral volume, and I've got some digital copies on sticks at the back, so if you want to pick them up, you can catch me after the talk, or we're playing all week at the Geoscience Forum over in the Sternwheelers. We'll have a booth there. Anyway, this is a picture of the Casino deposit. In Yukon, there's 19 documented deposits, and they contain over 15 billion pounds of copper. And beyond that, there's an additional 1,000 plus occurrences of copper that have been documented. Casino is the biggest deposit. It's world-class. It contains copper and moly, as well as gold and silver. Copper and molybdenum I've got highlighted because they're critical minerals. Western Copper and Gold is working on a submission for a panel review for YESA, and over a 25-year mine life, they are planning to produce over 4 billion pounds of copper and 330 million pounds of molybdenum. What's interesting is last spring, Rio Tinto bought into the project, and that's significant because Rio Tinto is a major company, and they've tweaked their investment strategy to focus on minerals that are going to be advancing greener energy. So their interest in Casino is significant. Zinc in the Yukon, we have a lot of zinc. The majority, but not all of it, occurs in what's called the Selwyn Basin, northeast of Tintina Trench. Over 25 deposits with 16 billion pounds of zinc documented, and another 900 plus occurrences. This is a picture of Kudzakaya. It contains zinc and copper, as well as lead, gold, and silver. They have a resource of almost 3 billion pounds of zinc and a reserve of 2 billion pounds. And it's one of many that are documented in the book. Nickel, platinum group metals, and cobalt. These are, nickel and cobalt in particular are known as battery metals. We have 84 nickel occurrences, 63 cobalt occurrences, and 66 PGM, platinum group metals, occurrences in Yukon. This is a photo of a drill at the Nickel Show deposit near Burwash Landing, and it contains nickel, cobalt, platinum, palladium, and copper. And you can see the resource listed here. And then I'll just name one other, and that's tungsten. Yukon actually has, of the 10 largest tungsten deposits in the world, 2 of them occur in Yukon, and this is a shot of the Mactung deposit up at Mac Pass. Tungsten's not only a critical mineral on Canada's list, but it's a strategic one because currently China dominates the world market in tungsten. They flooded the market in the early 2000s with tungsten, which drove the price down. It halted a lot of exploration and caused a number of mines to close. And then with low prices, they bought up a lot of the mines outside of their border. So right now they control all tungsten produced in China and a lot of the tungsten that's produced outside. So this deposit was recently taken over by Fireweed Zinc. And this deposit is something that could become not only economically important, but strategically important for Canada. So this is a graphic from the draft version of the critical minerals strategy for Canada, and it shows what they call the value chain of critical minerals. And I just put it up to show the different steps as they're characterized on an infographic: exploration, extraction, the processing and refining, and then the advanced manufacturing, and then recycling. And thought I'd just talk a bit about where Yukon might fit and contribute in this continuum. I'd say we don't really have a place at the moment anyway in the last 3 steps. There's no smelters in Yukon. We don't have any car manufacturing or cell phone manufacturing capacity here. And we are pretty small for these sorts of industries. But we do have a lot of the raw materials here in the ground. And so there's opportunities for us because we've got this geologic endowment. We have, as you've heard this morning from all the introductions, a long history of mining and a skilled workforce. And we've got a modern regulatory regime and are working on new mining legislation. So our role in meeting our goals, we, Yukon and Canada, have made some pretty ambitious plans to reduce greenhouse gas emissions. And that's going to require critical minerals and create more of a demand for them here and internationally. Energy security, we hear a lot about that these days, and I think if you lived in Ukraine, that would be a top-of-mind issue. In order to have a reliable supply of energy, we're going to need more critical minerals. We have the potential in Yukon to be a future contributor to the critical mineral space, as they call it. And we know that bringing deposits into production takes time. There's the lead time for the exploration and discovery and the delineation of the resources. There's commitments to complete land use planning, and there's legislative hurdles to overcome. There's assessments, and there's the social license that's involved with mining. But I think a lot of these challenges are bumping up against some of the critical timelines associated with climate change and the economic opportunities that these are presenting. So we'll see how those play out in the future of Yukon's mining.